Okay, guys, so welcome to the lesson today. Again, probably be going kind of quick due to the 15-minute time limit on this. Might not be quite as fast as the other day. Um, so the lesson today is on classifying matter. Go ahead and get out your notebook, pause and get out your notebook. I'll proceed as if you have them already, but you need to take some notes on this. The If I gave you a bunch of objects, then you would be able to classify those objects, and you could pick the way you wanted to classify them. You might classify a group of objects based on their color or on their, uh, their shape or what they're made of. Or if I gave you a bunch of cars, you classify them as sports cars or family cars or whatever. You could classify them based on some categorizing system. In chemistry, we classify matter, and we put all matter into one of two categories, and then we can break those two categories up into smaller categories as well. Our primary two categories that we will classify matter into would be either a pure substance or a mixture. That's it. You can take any piece of matter, no matter what it is, and you could put it into one of these two categories, either a pure substance or a mixture. We'll start with the pure substances because they're the easier ones. Um, if you have an element or a compound and that is what you have, then you will have a pure substance, period. Elements by themselves, compounds by themselves are pure substances, and they are the only pure substances. There is nothing else that can be a pure substance besides an element or a compound. And so those are our pure substances. So let me say that again. You might star this or asterisk it. If you have an element or a compound, then you have a pure substance. Period. End of story. That is what a pure substance is. An element or a compound. Those are pure substances. So some characteristics of pure substances. Well, what are pure substances? Well, first they have a defined composition. They are defined. For example, what is the definition of water? The definition of water is H2O, two hydrogens chemically combined to one oxygen. It is defined as H2O. You will never find water anywhere in the universe that is not H2O. There may be some other liquid substance like it, but it's not water. H2O is water. Salt, common table salt. What is its definition? Its definition is NaCl, one sodium combined with one chlorine, or more correctly, a ratio of sodium and chlorine together in a 1-to-1 ratio. The definition of carbon is a atom that contains 6 protons, 6 neutrons, and 6 electrons. Although there may be some isotopes that have different number of neutrons, they all have 6 protons, and we'll learn more about those later in the year. So pure substances have definitions to them. They're defined and they are always the same. They're also uniform, which means they're consistent. They don't change. For example, if I give you a glass of water, the whole glass of water is the same. It's not the top is the hydrogens and the bottom is the oxygens, but the whole glass is the same. And so they are defined and they are uniform, or they are consistent. That is a property or a characteristic of a pure substance. Another property or characteristic is that all samples are the same. All samples of a pure substance are identical regardless of where they come from. If we send a space probe to Mars, and we've got one there that just landed a few weeks ago, and it finds water on Mars, then it is going to find H2O. The water on Mars and the water on Earth would be the same. They are all the same, regardless of where they come from, all samples of that pure substance. If I find some gold in my backyard, it is the same as any other gold in the world. It's gold. Gold has a definition, therefore all samples of it are the same. And so those are two characteristics of pure substance, that they are defined and uniform, and that all samples of that substance would be the same. And so those are your two big characteristics of those pure substances. Now, we can break pure substances into two categories, and they're up here. If you have an element or a compound, Those are the two categories of pure substances. And so let's look at those two subcategories of a pure substance in a little more detail. You already know some information about elements. Well, what are elements? They're the most basic form of matter that exists under normal conditions. They are the building blocks. They're the bases of matter. And elements are made of smaller things, but we're not going to talk about that right now. And so this is what things are made of. They are made of elements. We cannot break them into smaller pieces by any kind of chemical process or physical process. So I can give you an element of carbon, and there is no way for you to change that carbon into smaller pieces chemically or physically. The only way to change that carbon into something different is a nuclear reaction. And so they cannot be made into simpler substances chemically or physically. The smallest part of an element is called an atom. And so atoms are the building blocks of elements. If I give you a chunk of gold, well, that gold is made up of a whole bunch of individual gold atoms. And all of those gold atoms are the same, effectively. There can be minor variations. We'll talk about that later. But they're effectively the same thing. And so there are 90 naturally occurring elements. 90 of the elements on the table are natural. Some people argue that number. Some people say 91, but generally it's considered to be 90 naturally occurring elements. Anything above 92 is man-made, and there are a couple of ones less than 92, technetium and promethium, I believe, or pacificum, that are not naturally occurring. And so 90 naturally occurring elements. And some examples, you know what elements are. Carbon, neon, gold, and calcium are some examples of elements. Compounds. Well, what is a compound? Well, a compound is where you take two or more elements and you chemically bond them to each other. And so, for example, water, it's two hydrogens and two oxygens, and they are bonded together. They're not just mixed together, but they are bonded to each other. They move together as a single entity, if you will. So those are what compounds are. So we have elements as a pure substance, and we have compounds as a pure substance. These are our two categories. Elements are the basic building blocks. You take two elements and you chemically combine them, and you get a compound. You can have more than two elements, and you get a compound. You can only separate these compounds by chemical processes. If we chemically combine them, that's a chemical process that bonds them together. We can chemically separate them. We have to undergo a chemical process to separate them, the breaking of chemical bonds. So we chemically bond them, we chemically separate them. Those are what compounds are. Some examples of compounds. Water, you know what water is. Glucose, C6H12O6, so a very necessary sugar for our metabolism in our body is glucose. Propane, if you have a gas grill at your home, you go to the store and you buy a gas tank for your gas grill, it's got propane in it, C3H8. And so you can see that all of these have multiple elements, at least two elements, and sometimes more than one atom of each element, and they are chemically bonded together. Those are compounds. Well, if we don't have a pure substance, if we don't have an element or a compound, the other major category is mixtures. And so what are mixtures? Mixtures are not pure substances. They are not an element or a compound. They are two or more substances that are physically combined. So we can take things and throw them together, and they can physically just simply mix. That is what a mixture is. If we chemically combine them, we create a compound. If we just throw them together and they're just sitting next to each other, then they are physically combined and they are just part of a mixture. Since they are physically mixed, we just throw them together. There's nothing special about them being with each other. We can just simply separate them via physical processes. We don't have to do a chemical process to separate them. Mixtures also do not have defined compositions, and not all samples are identical. So for example, Kool-Aid. If I asked 10 people in the class to make Kool-Aid, it is highly unlikely that any two of those samples of Kool-Aid would be exactly the same. Some people would make it more sweet. Some people would make it with more Kool-Aid flavoring. Some people would make it a little more dilute. Kool-Aid is not defined. There's no definition of Kool-Aid. People can make Kool-Aid differently. And so it's not all the same. They so different samples from different people would not be the same. There are two kinds of mixtures. We have homogeneous mixtures, and these are words I know that you've heard of before. So homogeneous mixtures is a type of mixture with the same composition. So this it it doesn't have a definition like pure substances, but homogeneous would have uniform composition like a pure substance. And so there's a little bit of it could be confusing if you're not careful here. Um, some examples of homogeneous mixtures are Kool-Aid, air, and alloys. If you make a glass of Kool-Aid, all parts of the Kool-Aid are the same. If you look at air, all parts of air are the same. Now, we can get into some details here, and we'll talk about this when I get back to class. But all the oxygen is evenly mixed. All of the carbon dioxide is evenly mixed. We don't have the oxygen in one part of the room and the carbon dioxide in another part of the room and the nitrogen in another part of the room. It's all evenly mixed. It's uniformly distributed effectively. Alloys, like this steel wheel there, that's an alloy of different kinds of metals mixed together. We don't have one kind of metal in part of the wheel, another kind of metal in a different part of the wheel. It's evenly mixed. It's got the same makeup throughout. Homogeneous mixtures are oftentimes called solutions. So the air is a solution. The Kool-Aid is a solution. The alloy wheel is a solution. We will talk in more detail about solutions when I get back to class on different kinds of solutions. In a homogeneous mixture, you cannot distinguish the different parts. If you look at Kool-Aid, you can't see the Kool-Aid mix, the water, and the sugar. It all looks the same. The alloy wheel there in that picture, it looks the same. You can't see the different components. In a heterogeneous mixture, however, this mixture is not the same composition throughout. Some examples of heterogeneous mixtures might be salt and pepper. We might have a little chunk of salt there, or sorry, a higher concentration of pepper. Looks like there might be more pepper in this part. It's a little darker here. It's a little lighter over here. It's not all evenly mixed. Dirt. You can see there are different pieces. You can see, we have these little white pieces. We have darker areas of the dirt, and so it's not all evenly distributed. And then the last one I have here, spaghetti. Well, we have spaghetti sauce. We have meat sauce. We have the noodles. And so it may not all be evenly distributed. One fork might not be the same as another fork full of spaghetti. And so there's differences there. You can usually easily identify different components in a mixture visually. You can see the parts. I can see the salt and pepper. I can see the noodles and meat sauce. I can see the dirt and the rocks. I can see the different parts. And that's one usually easy way to identify a heterogeneous mixture from a homogeneous mixture. In a homogeneous mixture like Kool-Aid, you can't see the parts. It all looks the same. It just looks like this Kool-Aid drink that you would drink. An exception to this are solutions. Solutions, which we're just talking about, you typically can't see the different parts in that mixture. So sometimes solutions can be confused with pure substances because we can't see the different parts of a pure substance either because it's just one thing. And so you have to be careful with homogeneous mixtures and sometimes confusing those with a pure substance. Homogeneous mixtures are not a pure substance because they are not defined. There can be different kinds of those homogeneous mixtures. For example, steel is a homogeneous mixture, but there are different kinds of steel. There's stainless steel and there's regular steel, and there's other various kinds of steel as well. There's no definition of steel. Steel is a mixture of various metals, and they can have different kinds of mixtures to make different kinds of steel. And so that is the difference between the heterogeneous and homogeneous mixture. All right, we're going to do this later, and so heterogeneous, homogeneous, those are mixtures. Elements and compounds, those are pure substances, and so make sure that you know the differences between those. I have a worksheet for you to work on. I'll also post a video that's separating the mixtures because that's going to be added onto this, but I'm out of time effectively, and so go ahead and watch the second video on separating mixtures as well, and then you can work on the practice sheet as far as making sure you understand what we're talking about here today.